Okay, we're beginning Chapter 4, Section 2, Graphing Linear Equations. I'm going to go ahead and add a little piece of graph paper. And let's see, I'm gonna move it first and enlarge it a little bit. No scale. There we go. Okay. And then, there's a couple of things we have to do. First, we have to just plot a standard one. We're just going to take an equation, x plus 3y equals 6. Okay, and the first step is to rewrite the equation in function form. We don't have to do this, but it's nice to. It'll get you ready for the future as well. So we're going to subtract x from both sides, and we're going to put the x in before the 6. It could be 6 minus x, or it could be negative x plus 6, and that's the way we're going to do it. So 3y equals negative x plus 6. Okay. And this is close. If we wanted to continue on, we would divide both sides by 3, but we're gonna save that for later. The second step is to put it in a table. Okay, so we're gonna put a little XY table. The book does it a little different. I like to do it vertically. X and Y go this way, and then you can plot your points almost immediately. And I like to start with 0 for x. If x is 0, you know what? Let's go ahead and move backwards a step. I said I didn't want to do it this way, but we're going to go ahead and do it this way anyway. So we're going to get y by itself, which is the function notation. And the 3's cancel here. The 6/3 becomes 2. And we're sort of stuck with a fraction here, but I think we can live with that. Y equals negative 1/3 x. This is what this turns into. Negative x divided by 3 is the same as negative 1/3 times x plus 2. 6/3 becomes 2. Okay, so if I put 0 in for x, then this whole thing becomes 0. 0 plus 2 is equal to 2, so y is equal to 2. Back to blue here. So this is like a point on our graph, 0, 2. Okay, it's like a point 0, 2 that we're going to put on the graph down here. Okay. So that's the first thing. Now, I kind of did this real quick. I just threw it in there, and hopefully you understood. But I'm going to go ahead and try something else. And it's not going to work out so well. So just pay attention real quick, then we'll erase it and try again. I'm going to put 2 in for x. That's negative 1/3 times 2. So y equals negative 1/3 times 2 plus 2. And this becomes negative 2/3. So y equals negative 2/3 plus 2. Now I can add these together, but it's a little difficult. I have to change 2 into 2 1s into something thirds. So I'm going to change this into thirds multiplied by 3. So this is 6/3 is the same as 2 1s. That's back where we were up here. Negative 2/3 plus 6/3 is 4/3. So y is equal to positive 4/3. And that's a little 4/3. It's a little hard to graph. I could do it in the x direction. I'd go over 2, and then I'd go up 4/3, which is just a little more than 1. It's like 1 1/3. It'd be about there. And I'd have to put a point in. And that's fine. You can do it that way. And this works. But I'm going to back up, and I'm going to show you that if we choose a better number, we're going to get something that works really nice. Okay, so it's not going to let me erase anymore, so I'm going to have to do it the hard way. We're just going to go real fast and to kind of scribble this out. Be patient. Bear with me. This is an important activity. Okay, so we're gonna make it work. So that way it didn't work very well. We're not going to use this 2. 2 isn't the best number. Sometimes you have to choose a number that works really well, and 2 is not always it. It's not always just the next number. Sometimes there's a very specific number that you want to use. Okay, for instance, we're going to want to use something that works with 3. So positive 3 works with 3 just fine. Negative 1/3 times 3 is negative 1/3 times 3. 1 times 3 is 3, and 3 times 1 is 3, so it ends up being negative 3/3, which is the same as negative 1. Okay, so a 3 works nicely. That becomes y equals a -1 plus 2. So we get that. -1 plus 2 is +1. And so our second point is going to be 3 and 1. And our third point, I'm just going to go ahead and throw a -3 in. If I put a -3 into this equation, into x, if I put -3 in here, it's going to end up becoming a +1 instead of a -1, and a +1 plus 2 is actually 4. So my third point is going to be -3 and +4. Alright, so now I have 3 points. It only takes, geometry, you'll find out that it only takes 2 points to form a line. But if you want to make sure you didn't make any mistakes, you go ahead and add a third point. So I want you to always graph 3 points. Graph 3 points, and we'll get along fine. If you graph 2, you're going to make a mistake and you won't know it. But if you graph 3, and one of them doesn't match, let me show you. 0, 2, our first point is 0, 2. That's 0, up 2. That's our first point. The second point is 3, 1. 1, 2, 3, up 1. Get rid of that. I don't want to restart my computer. And then the third point is -3. 1, 2, 3, up 4. Okay. And I can see that these 3 lines connect nicely. Okay. You know, not perfect, but nicely. If I had drawn the little dots better and drawn the line a little better, you'd see that it was perfect. Back up a little bit. If I had put this point somewhere, if I'd done it wrong, put the point right here instead. Is it working? Yeah, there we go. Oh, I see, because it's still got on a straight line. If I'd put the point right here instead and I tried to draw the line, then it is obviously missing. I'm missing this line. You can't draw, unless all 3 of them are right, it's not going to make a straight line. It's going to make more of a curve type of thing. Alright, so you have to make sure the points are in the right spot. -3, up 4. And you can notice that my slope, let me go ahead and draw this, and I'll teach you a little quick slope lesson. This will come in handy later. My line goes down 1 over 1, 2, 3. Down 1 over 1, 2, 3. And that's going to happen everywhere I go. So this actually has a slope of -1/3, which means down in the negative direction 1 over in a positive direction 3. Down -1 over 3. And this is something that's going to show up later. You're going to see this over and over. It's kind of a neat pattern. So look forward to that. Okay, so this is the table. And this was writing it in function form. So you write it in function form if necessary. You don't have to, but it's definitely easier. Write a table, an XY table that converts to your points, and then graph 3 points. You have to graph 3 points to make it work. Okay? Let's see what happens if I add another graph. We're going to move it again, make it a little bigger again. Okay. Back to this, and I got to show you a couple of special cases. So I showed you a line that was kind of silly. It's like y equals, we used -1/3, but we'll just say 2x plus 4. Okay, this is a line that has an x and a y. You can plot points on it. You've got an x and a y. And you put in 0 for x. 2 times 0 is 0, plus 4 is 4. So the y is equal to 4. You put in 1 for x. 2 times 1 is equal to 2. 2 plus 4 is 6, so you put in 6, and that's what y is. So the x is 0, then y is 4. X is 1, y is 6. You do this one more time. 2 times 2 is 4. 4 plus 4 is 8, and you have kind of a pattern here. We're going 0, 1, 2. We're going 4, 6, 8. You could probably guess that it's going to look like this for the next one, and if you put it in, it would work. And you draw the line, and it's just going to keep on going. But we have some strange lines that pop up, and kids always get confused. What do I do with it? Say we have something like x is equal to 2. Alright, and we try to put something in here like this. X is equal to 2. What is y? And the best way for me to explain this to you is to do the same thing for y. And we'll just talk about it real quick. Y is equal to 1. Make a little xy table, xy chart. Okay, and what do you put in here? Okay, so for the green one, x is always 2. X is 2. So we're going to put 2 in for our 3 points. And it doesn't matter what we put in for y. If we put in 0 for y, if we put in 3 for y, if we put in -3 for y, it doesn't matter. X is always 2. And the same thing for the pink one. Y is always 1. Doesn't matter what you put in for x. You put in 0 for x, y is equal to 1. You put in 2 for x, y is equal to 1. You put in -2 for x, y is equal to 1. So if I draw this line, the pink one, we'll go back to the green one just because we started with that one. Probably got the. Okay, so 2, 0 is right here. Over 2, up or down 0. Okay. The next one is over 2, up 3. And the next one is over 2, down 3. This is point 1, point 2. Oh, sorry, point 1 was actually this one. This was point 1, point 2, point 3. This is the first point, the second point, and the third point. Okay, and this makes a nice vertical line. All right, so whenever you get an equation where there's no y, it's just x is equal to some number, it's a vertical line. And if you can't remember whether it's vertical or horizontal, I never can. I always have to think in my head, do a real quick chart and say, well, it doesn't matter what it is, x is always 2. So x is 2 here, x is 2 here, x is 2 here. I can start adding points, and I know it's a vertical line. And the opposite is true with the pink one. This is the first point. Ooh, should switch to pink. This is the first point, this is the second point, and this is the third point. 0, 1 means I go 0 in the x direction, and 1 in the y direction. 2, 1 means I go 2 in the x direction, 1 in the y direction. And -2, 1 means I go -2 in the x direction and 1 in the y direction. And draw a line, I get a horizontal line. Okay, so if it's x equals a number, that's a vertical line through that number. If it's y equals a number, it's a horizontal line through that number. See, this is 1. This is 1 up. It goes this direction, but it's always 1 up. This makes this kind of a horizontal line. Okay, so these are important. They're gonna throw you these in the book. They're gonna ask you to do these, and you're gonna come to me and say, I don't understand what to do with this. This is me telling you what to do with this. Try to remember it. Okay. Horizontal and vertical lines, those are important. They do show up. Other than that, you just plot the points using the table. Have fun with this one, and come to me with questions.